Oh, hi. Let me make my face bigger. Wow, there I am. Cool. So today, in this little mini lesson, I'm going to introduce you to something that is absolutely critical for this class. Okay, it is the answer to probably 100% of the questions that I ask, and that is the notion that form determines function. And so the reason why things do the things that they do is because they are shaped the way that they are shaped. This is true of all material things. Anything that is physical obeys this rule. Okay? So all of the interactions, all of the properties, all of the stuffy stuffs that we talk about in biology all comes down to shape. Right? And so things do things because of their shape, which means if I want to change the way something does something, I need to change its shape. Okay? And the fact that you can achieve a change in function through a change in shape is key to understanding how, on a cellular level, most of our things operate, if not all of our things, right? Because our cells don't have any kind of sensory abilities. Right? They don't have brains. They don't have little eyeballs to look at things to say, oh, I need to say hello to Jim today. Right? No. All they can do is change shape. Right? And so we have tiny little shapes like hydrogen. Right? Hydrogen has its properties because of its shape. Right? This doesn't go away just because it's super tiny. And all of the things that we talk about are physical things, right? Sometimes it's hard to imagine them being physical because they're so small. But you got to remember, they are physical things, and they interact physically the same way that big things do, right? So if you blow up the picture of what you're thinking about in your mind, right, and you think about how they would touch each other if they were big, they touch each other the same way when they're small, right? So understanding that shape determines function is absolutely critical to understanding a lot of the things in this course. Okay, so don't forget that. You're going to hear me say it 150,000 times. I'm going to ask you 150,000 times, and the answer is always going to be, because of their shape. Right? So I want to change their function. What do I do? Change their shape. Okay? Along the way, I'm going to want you to tell me how a specific shape is responsible for a specific function. Right? And so if I got a hammer, right, the hammer's function is determined by its shape. Right? So if I want to hit a nail, which is this thing right here, okay, the shape of this hammer allows me to very effectively drive that nail into a piece of wood or other substance that I want to drive that nail into, right? The weight of the hammer is near the top. I have a long handle to create a lever, right? I have a flat surface area that's appropriate for hitting the size of the nail, right? The more narrow that surface area of that head of that hammer, the more force in that particular area, right? So I don't want a giant head for a tiny nail. Okay? And likewise, I don't want a tiny head for a giant nail, right? I want the appropriate shape for the appropriate function. A nail is shaped the way it is for the same purpose, right? It has that top little thing so you can drive it in, right? Now, if I wanted to put a piece of pizza through a piece of wood, right? No matter how many times I smash it with that hammer, smash, 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 it ain't going through that wood. It's a piece of pizza, right? The pizza's shape on a molecular level isn't appropriate to create the properties necessary to pierce, to penetrate, to deeply go into the wood the way that the nail is, right? And so on a macro level, we see these shapes. We can easily imagine how a hammer works with a nail. But these principles transfer down to the micro level as well, right? The reason why the pizza is so soft and floppy and can't go through the wood is because of the way that its molecules are shaped. Those molecules are shaped a certain way that makes them bond a certain way, and the bond between those pizza molecules is loose. And so the pizza is loose, right? Whereas the bonds in the molecules of the nail are really tight. And so that nail's nice and hard, I can drive it in. Right? Those molecules possess those properties because of the elements that make them up, right? If the elements are shaped in a way that bond really tightly in a nice little organized way, they'll be a solid, right? If those elements bond loosey-goosey, right, the molecules will be loosey-goosey, and therefore the substance will be loosey-goosey. That's it. Bye.